Okay, guys, this is going to be our 6.4 notes. So you can get all the vocab up top. Just go into your book, go and then just click on all the words in the first section of it. You'll see it says objective and vocabulary. So you can get the top 4 words up there, or else you'll be able to see them down here. So now we're going to take our concept of working with exponential functions and apply them to specific scenarios. So the general exponential function is your initial value times your multiplier to the number of times multiplied. So very often this multiplier, you have to find it. Sometimes whenever you're looking at a table, you take any y divided by the y right before it, and then you find your multiplier. Sometimes they'll tell you what your multiplier is. If they say you triple, it's times 3. If they say you double, it's times 2. Or they might give you the multiplier. Sometimes, very often, what happens in the real world, things don't just double or triple. They grow by a percentage of themselves. So what we're going to say is we have a growth rate. Okay? So that can be given in the story problem, typically. Your growth rate is how much you grow by as a percentage every round. Whatever you're measuring by. It could be a day, it could be a month, it could be a week, it could be an hour, it could be whatever. Your growth rate is some percentage, okay? Now, since we're growing, we're going to be bigger than 100%. And remember, 100% is represented as 1. So to get our growth factor, you just take 1 plus whatever your rate was. And that's what shows up in this formula. So now, if we know we're going to have exponential growth, say you're reading a story problem that says you have some amount that is growing at a certain percentage. It's not doubling or tripling, so we don't have a factor. We have a growth rate. You take that rate, add it to 1. That now becomes what used to be b. You see how that's the growth factor? So 1 plus the rate is the factor. The initial value plus your factor times the number of times grown. So now let's just apply it in an equation. So your first example, let me shrink this down a little bit. You should have your notes, so you should be able to see this at home just fine. I can't find that sweet spot where it fits. Okay. So the inaugural attendance at an annual music festival with 150,000 people. The attendings Y increased by 8% each year. So we're going to write an exponential growth function. The general form is Y equals A times B to the X. But since we know we have exponential growth, it's Y equals our initial value times 1 plus our rate. T represents the time. Notice how we're changing this now. All we're doing is we're saying we're going to find our factor. But our factor depends on our growth rate. So now, okay, the attendance was 150,000. That's our A. Increases by 8%. That's our rate. So we're at Y equals 150,000. Sorry, I won't put the comma in because Big Ideas doesn't like that. Outside of 1 plus 8%. But let's change this to a decimal just so we have something easy to work with. Remember, decimal to percent, you move it two places. So 1 plus 0.08 to the, and we're at t because it's t years, okay? Now, you need to combine these so it looks like a factor. So we're at 150,000 outside of 1.08 to the t. This is your final answer. And when you're working on these things on your homework, make sure that that gets put in that way, okay? Now, how many people will attend the music festival in the 5th year? All we have to do here is plug 5 in for t. So the amount of people Y equals 150,000 times 1.08 to the 5th. And when you plug that into your calculator, Let me go to Desmos real quick for you. Now remember, the B you have to put to the fifth. So when we get this number, they're gonna have us round it. Let's check to where they have us rounded. The nearest 1,000, so let's go back. The nearest 1,000, let's get this work out of the way. The nearest 1,000 is going to be right here, okay? Remember, 1,000, not thousandths. So we're rounding to the 0, 3 means we stay the same. So we're gonna end up with 220,000 people. So again, quick recap. We know it's exponential growth because, well, one, they told us, and two, we have a number that's increasing by a percentage over and over again. So we know we're growing by 8% every year. It's not adding, we're growing. That's different. So it was y equals 150,000 outside of 1 plus 0.08 to the t. Then we just had to plug in 5 for t. Okay? I am going to look at the monitoring progress. I'm not going to plug it all in for you, but I want to look at it because this concept gets a little bit hard. I want you to try the monitoring progress on your own. If you want to stop, pause this, do the monitoring progress, and come back, I would suggest doing that. So, a website has 500,000 members in 2010. The number of members increases by 15% each year. Again, we're increasing by a percentage over and over again. So y equals 500,000 outside of 1 plus our r, that we're going to call 0.15. So 0.15 to the t. We knew it was exponential growth, so we just look for our exponential growth formula. But we want to write this as a factor, so it's 500,000 outside of 1.15 to the t. How many members will there be in 2016? Remember, t represents how long have we been doing this. Well, if we started in 2010 and we're measuring in 2016, t would equal 6. So all you have to do is go to your Desmos, plug in 500,000 outside of 1.15 to the 6. So go ahead and do that on your own, and then that is example 1. Thank you very much.